In today's video, I'll be showing you how the most common types of valves work. Let's start with the most common valve, ball valve. As the name states, there is a metal ball with a hollow bore that is approximately the size of the inner diameter or ID of the pipe. This is an important feature because the valve is open and it doesn't obstruct the flow. This feature also allows the valve and the following pipe to be inspected or drain snake. The ball design also allows for maximum contact area, which results in much tighter seal. They are durable, performing well after many cycles without leaks, because the valve seals are not directly exposed to inline elements and debris. They are also very reliable. They can survive in dirty and harsh environments and can operate even after long periods without regular cycling. I have personally seen ball valves operate even after 40 years in an industrial setup. They're best suited for shut-off applications thanks to their quarter turn or 90-degree open/closed design. The quarter turn action also makes ball valves very difficult to fine-tune and control output, so they are not recommended for fine flow control. Another shut-off valve is a gate valve. It works by raising and lowering a gate. Similar to ball valve, they operate without obstruction and leave the pipeline open for inspection. Lowering and raising the gate puts a lot of wear and tear on the spiral stem, and they are not recommended for flow control. When the gate valve is open and operational, debris can settle in the seal or seal erosion from the flow occurs naturally. Furthermore, the sealing surface around the edges of the gate provide a very thin contact area, making gate valves very prone to leaks. Gate valves, however, are used for temporary work on the pipelines due to their lightweight and their compact design when compared to ball valves. Their seals are regularly maintained to prevent leaking. Next, we have the most common household valve, which is the globe valve. The diverting arms provide the greatest resistance to flow, allowing for very easy and precise control. Globe valves are designed to be directional. If the flow is reversed, then the constant pressure damages the seal around the stem, which can cause leaks or total failure of the valve. They are also used at end termination shut-off valves. When installed correctly, for example, at a tap or faucet where flow control is required, as well as a perfect shut-off with an excellent seal. Globe valves should never be used as shut-off valves in between a piping system. Now there is a variation when it comes to globe valves, and that is solenoid or mag valves, which is magnetic or coil-based. Important note is that the diagram shows a normally closed valve. When current passes through the coil, a magnetic field is generated, which pulls the metal stem, compressing the spring. As long as the voltage is present, the valve will remain open. And as soon as the power is cut off, the spring pushes on the stem to seal the valve. Lastly, we have the other valves that are not as common, but still very essential to any system. Let's look at another quarter turn valve, the butterfly valve. In the little diagram, you can see that a metal disc pivots to restrict flow, hence the name butterfly. They are perfect for controlling the flow, and they are still regarded as quarter turn because of the disc action, even though some of them come with a small gearbox for even finer flow control. Butterfly valves are not used for shut-off applications as they are very prone to leaks. Next, we have check valves. Check valves never get any attention because they are basically set it and forget it type of valve. They only permit flow in one direction, meaning they are directional. In the diagram, the spring compresses the disc is released from the seal when there is flow. When the flow changes direction, the disc is pressed against the seal. They are best suited for maintaining a separation, for example, keeping hot and cold water from mixing together under the sink, or as a safety net to prevent reverse flow in a fish tank. There's another variation to check valves with a small change. If the check valve seal is extended, then a check valve can be made into a pressure relief valve, where the valve opens and expels excess pressure buildup. The diagram shows preset relief valve, where the spring is designed and calibrated to reduce pressure buildup. The spring compresses till the seal is pushed past the sealing chamber, and then pressure is released until the spring overpowers the pressure and reseals the valve. These valves have saved lives by keeping operating pressure within safe range. And the best part about relief valve is that the failure occurs at the seal. And when that happens, the relief valve just prevents any pressure from building within the system. So a quick change and you're back up in operation. In conclusion, we can see all the different types of valves working. They can be easily identified based on their action, or their seals, or their flow control. The important thing is to keep them operational as a safety net. I hope you liked this video. Thank you for watching.